Dear students, let us do some problems in kinematics today. In first problem, see that problem is, please read that problem. A projectile, it is based on projectiles two-dimensional motion concept, projected on the surface of the earth and flies for 5 seconds and falls 200 meters away. Neglecting air resistance, the angle of projection is, some options are given. Now how to do this problem, let us see. It is a two-dimensional problem and it was projected on the surface of the earth. So let us imagine a projectile. This is x-axis, this is y-axis. From here say body is projected and it was given in the problem, it is taking 5 minutes to reach the surface of the earth. Flies means it is in air, that means it is reaching here and the time taken is given 5 seconds. This is given, and then in 5 seconds it is given it is reaching 200 meters away. This is 200 meters from here to here. That means range is given, that range OA is equal to 200 meters. This is also given in the problem. Then what do you want? Angle of projection. Say body is projected like this with a velocity u and this is angle theta. Now you want to find what is angle of projection. Theta is equal to how much? This is the problem. How to solve the problem? That is the question. Now if you see, the velocity of projection was not given, but you want angle of projection. How to solve this problem? And two things were given. Time of flight, t is nothing but flies means time of flight, r is range. Let us recollect the formula. What is time of flight? Time of flight is 2u sin theta by g. This we know. Therefore, time of flight if you write 5 is equal to 2u sin theta by g. This if you simplify, 5g is equal to 2u sin theta and u sin theta is equal to 5g by 2. This is equation 1 you are getting. So, the equation 1 what we got? U sin theta is 5g by 2. Next, range given. What is the formula for range? Range we know r is equal to u square sin 2 theta by g. But here we write range like this. R is equal to what is range? Horizontal component of velocity. One more formula is there. This you might be knowing. Horizontal component of velocity into we know time of flight. Better if you write this formula. This is the basic formula. From this formula we obtained this formula if you remember the derivation. So from this what do you write? Range 200 is equal to horizontal component. You know velocity can be resolved into components. This will be u cos theta, this will be u sin theta. These are all the fundamentals of projectiles. So this will be u cos theta into what is time of flight? Time of flight already given 5. So from this what is u cos theta? U cos theta is equal to 200 by 5. 200 by 5 is what? 40. Equation 2. So now you know u sin theta, you know u cos theta, you want angle of projection. How do you get angle of projection? Divide these two equations, u sin theta by u cos theta. If you divide, what is u sin theta? 5 by 2, g let us write 10 by what is u cos theta? 40 you got. Substitute that u cos theta. Now simplify, 0 0 gets cancelled. You are going to get 5 by 8 here, u and u gets cancelled. So it is tan theta. So the angle of projection theta is equal to tan inverse 5 by 8 you are going to get. This way you can solve the problem. So the answer is option 4, tan inverse 5 by 8. So this is the first problem. Now coming to the second problem, let us see the question. A particle falls from a height of h. In the last 0.2 seconds, it travels 6 meters. Find the height. Different options are given. This is one dimensional motion problem. Let us see this problem. Say a body is falling freely. It is dropped. We don't know how much time it has taken to fall down. But what is given? In the last 2 seconds. This is last 2 seconds. That time say t prime 0.2 seconds. In this last 2 seconds, how much distance it has travelled? 6 meters distance it has travelled. This is given. So this is h given. And this time is given. Now what do you want to calculate? What is the total height? Say this total height is h. We want to calculate this height. How do you calculate this height? Now let us divide this total journey of the body into A, B, C. From A you have dropped with 0 velocity, it reached to B, from there B to C, and time given, distance given. Now to solve the problem, as it is falling down, we can take A is equal to G is equal to 10 meter per second square. Then for part BC, let us use the formula S is equal to ut plus half at square. If you use this formula, by the time it reaches here, say the velocity is v, let us calculate that velocity. B to C, the distance is 6, and here the velocity is v, and here to here the time taken is 0.2 plus half into A means G into T square, 0.2 square. From this we have to get, let us see, this will become 0.2v plus, this will be 5 into 0.04 if you simplify. So this is 0.2v plus 20. That means if you get 0.2. Therefore, if you bring 6 minus 0.2 is equal to 0.2v. So this comes up to 5.8 is equal to 0.2v. So v is equal to 5.8 by 0.2. So this you are going to get 2.9. Decimal and decimal gets cancelled. 29 meters per second velocity we are getting, and by the time the body comes from here to here, the velocity is becoming v. Now from A to B, what is the distance travelled? Let us take this. This distance travelled, total height is h, and here already 6 given. So this is h minus x meter. Now to find out the total height, let us consider for part AB you take. For part A to B, again use the same formula, S is equal to ut plus half at square. What is S? H minus x, 6 is the distance, h minus 6, as 6 meters already given, and what is u? 0 into, from here to here, what is the time taken? As that time was not given, now by the time it reaches to B, you got the velocity V as 2.9. 2.9 is the velocity at B. That is initial velocity for the journey BC, but that is the final velocity for the journey AB. Therefore, now to solve the total height for part AB, what do you write? You know initial velocity, you know final velocity, you know distance, you know acceleration. So use the formula v square minus u square is equal to 2as. This is the equation of motion that we know, and in this, for journey AB, v is the final velocity. Already this velocity you got 29 square. It is a freely falling body, u 0. As it is falling down, a is equal to g is equal to 10, and distance travelled is h is minus x. So now if you solve this problem, 29 square, if you calculate, you get 841 is equal to 20 into h minus 6. Just simply you solve it. So if you solve, h minus 6 is equal to 841 by 20. So this 841 by 20, how much you are going to get? 4, 2, 0.5 by 10. So you are going to get 42.05. You are going to get, you want h. So h is equal to 42.05 plus 6. If you add 48.05 meters, you are going to get. This way you have to solve this problem, and the answer is 48.05, and the first option is the correct option. So answer is 1. Let us see the third problem. The problem is a staircase has 5 steps, each 10 centimeters high, 10 cm wide. Ball is placed at the top of the staircase. What is the minimum velocity horizontal to be given to the ball so that it directly hits the lowest plane? To solve the problem, it is a horizontal projection problem. Let us draw a simple diagram. Staircase we can draw like this. These imagine steps. So 1, 2, 3, 4, say 5. These are the steps that you take. This is the first step, second step, third step, fourth. Let us take from here 1, 2, 3. This is fourth. This is the fifth step. And now from first step, a ball is thrown horizontally with a velocity, and it is reaching the fifth step like this. That means it is coming up to a horizontal projectile. This is the problem. In this case, what is the total height from which each step was given 10 centimeters wide, 10 centimeters height given in the problem. So, the total height from which it is falling is 5 into 10, 50 centimeters, and this can be taken as half meter. And what is its range? You are projecting from here, say a point B, and it is reaching the point B, fifth step, that is the lowest point. And what will be the range? The range R will be from here to here, say this point, if you take it as O, 5 steps it is taking, 1, 2, 3, 4, 5. It is projected from the first step. Fifth step it is reaching means 5 into 10, its range is 50 centimeters, and this is again half meter. So, its range is half meter, height is half meter. Then how do you get the velocity of projection? This velocity of projection you want to calculate. In horizontal projection, you know range is equal to, this is the range. How do you get the formula? U root 2h by g. This formula directly you have to remember. If you forget, you can obtain this formula, S is equal to ut plus half at square. From this formula you can calculate S is distance travelled, or U, and what is t? It is falling from here to here. So, t is time of descent, root 2h by g plus, as in the horizontal direction acceleration is 0, in the vertical direction a is equal to plus g. This is a is equal to plus g in this vertical direction. In horizontal direction a is equal to 0, so this term becomes 0. So, r is root 2h by g. This formula directly better you remember. Now, substitute all the values. Range is given half, u root 2 by g you can take 10 into what is h, half. This if you simplify, what you are going to get? The velocity. 2 and 2 gets cancel. So, half is equal to u by root 10. So, 1 by 4 is equal to u square by 10 you are going to get. So, u square is equal to 10 by 4. 10 by 4 is 2.5. So, u is equal to root 2.5 meters per second. So, u is equal to, u square is 2.5. So, u is root 2.5 meters per second. So, answer is 3. Let us see the fourth problem. The fourth problem is the equation of motion of a projectile is given, y is equal to 12x minus 3 by 4 x square. Horizontal component of velocity is given, g value given. What is the range of the projectile you have to calculate? Let us see what is a projectile. Projectile is a two-dimensional motion. So, x and y you take. From here I projected a body with a velocity u at an angle theta, then it strikes the ground somewhere here. This distance we call it as range. This is the maximum horizontal distance. Travelled by the body. So, this range you have to calculate, and equation of trajectory given. What is equation of trajectory given? 12x minus 3 by 4 x square. This is y is a function of x given, y depends on x. Suppose in this journey of the body, let us take a point P at any instant of time. To locate the point, how many coordinates you require? X comma y. This is the vertical distance travelled and this is the horizontal distance travelled. This is the situation at any instant of time. Now, range means the horizontal, maximum horizontal distance travelled by the projectile. Maximum horizontal distance means when you have projected from O, it is reaching to A. So, at A, simple mathematical knowledge, coordinate geometry knowledge if you apply, at A what happens? A is point on x axis. Point on x axis means y coordinate is what? 0. Then this implies OA is equal to range R. As this is a point on x axis, y coordinate is 0. Y coordinate is 0 means here x OA is equal to R means x is equal to OA is equal to R. So, if you substitute here 0 is equal to this value, you substitute here 12 R minus 3 by 4 R square. This if you simplify, 3 by 4 R square is equal to 12 R. Simple mathematical simplification, R and square gets cancelled. So, R is equal to 12 into 4 by 3, 4 times it will cancel, 4 4 16. So, the range will be 16 meter, that is the answer. So, option is second option 16 meter. So, second option is the correct option. Let us see the fifth problem. What is that problem? Maximum height attained by a projectile and its horizontal range are equal to each other if the projectile is projected at an angle given by. In this problem, say draw a diagram of projectile. This is x and y, you know, body is projected and reaching the ground like this. This is maximum height and this is range r. And what is given in the problem? Height and range are equal. Then what is the angle of projection? Theta is how much? Angle of projection. So when height and range are equal, what is the height formula? Let us recollect. U square sin square theta by 2g. What is range? U square sin 2 theta by g. Simply if you calculate, g on both sides gets cancelled, u square both sides gets cancelled. This I can write sin square theta by 2 is equal to sin 2 theta, you know, 2 sin theta cos theta. Simplify, you will get the answer. Here sin and square gets cancelled. If you take cos to this side, sin theta by cos theta is 4, tan theta is equal to 4. So theta will be what? Tan inverse 4. So the angle of projection will be tan inverse 4, and the third option is the correct option, and third is the answer. Now let us see the sixth problem. See, in this problem there is a target and a gun is fired, the bullet has to hit the target. Height you have to calculate. Let us see, there is a target T and gun is positioned somewhere here and bullet is fired from the gun with a velocity. What is that velocity given? 500 meters per second given. So it is a horizontal projectile problem and it should be at what height? Above the ground, so that it hits the target. And the target is at what distance? 100 meters away given. From here 100 meters away. Here one point you have to remember, if the gun is positioned exactly above the target, the bullet will miss the target. That you have to remember. It is a horizontal projectile problem. So now you have to keep the gun at some distance away from the target at some height h. That height you have to calculate, then it traces a parabolic path that is called horizontal projectile, then it hits the target, the bullet hits the target. Again, like in the previous problem, this will be the range, this will be the height. A range will be u root 2h by g. This formula directly you can use, and in this you want to calculate height. So range is 100 meters given, it is kept at a distance of 100 meter. U was given 500 and root 2 into h. G value in the problem was given as 10. This you have to simplify. If you cancel, 1 by 5 is root h by 5 you are going to get. So 1 by 25 square on both sides, h by 5. So h is equal to 5 by 25. 5 by 25 is 1 by 5 meter, but the options are in centimeters, so you have to convert. So 1 by 5 into 1 meter is 100 centimeters. So if you simplify, 20 centimeters height you will get. So the answer is second option is the correct option, 20 centimeters is the height. Now coming to seventh problem. Just see what is the problem. A body projected with a certain kinetic energy has range r. The kinetic energy will be minimum at a position of the projectile when its horizontal range is, kinetic energy is minimum. See here, body is projected with a velocity u, then it strikes the ground. This is the range given, but I want energy will be minimum. What is kinetic energy formula? Half mu square, and a Ke is equal to minimum implies u is equal to minimum. If energy becomes minimum, kinetic energy becomes minimum. And now in the problem, the kinetic energy will be minimum at a position of the projectile where kinetic energy is minimum. You know, when a body is projected at a certain angle, we have resolved this into two components. See, this is u cos theta and this is u sin theta, and throughout the path of the projectile where velocity will be minimum, horizontal component of velocity, you know, remains constant, and at maximum height also the horizontal component of velocity is u cos theta. If you observe throughout the journey, at the time of projection velocity is maximum, and at maximum height velocity is minimum. So at maximum height u is minimum, that is u cos theta. Therefore, that implies kinetic energy is minimum. Kinetic energy is minimum means at maximum height, what is the range? It will be exactly half of the range. Therefore, it will be the position of the projectile where kinetic energy is minimum is what? R by 2. So, the option is 3. So, third is the correct option. Coming to 8th problem, let us read the problem. Projectile thrown at certain angle of 30 degrees with the horizontal has a range R1 and attains a maximum height H1. Another projectile thrown with the same velocity at an angle of 30 degrees with the vertical has range R2 and attains a maximum height H2. Then the relation between R1 and R2. First it is projected, say let us see, it is projected at an angle 30 degrees with the horizontal with a velocity u as it is given. Then range is given R1. Next, another projectile is thrown with the same velocity at an angle 30 degrees with the vertical. That means if you draw another projectile, it is thrown at an angle of 30 degrees with the same velocity, then it strikes the ground R2. Then what is the relation between R1 and R2? This is the question. How do you solve the question? Here always the angle of projection we will measure with respect to the horizontal. Here angle say theta 1, 30 degrees given. Here what is the angle with respect to the horizontal? Say theta 2. This theta 2 will be 90 minus 30, it will be 60 degrees. Here the angle of projection is 30 degrees, range is R1. Here angle of projection is 60 degrees, range is R2. As the angle is becoming double, 30 is becoming 60, you cannot say range also doubles, that is wrong. Here what is the range formula? R is u square sin 2 theta by g. And here find out the range R1 in the first case, u square sin 2 into 30 by g. That is u square sin 60 by g. That is u square by g sin 60 is root 3 by 2. Similarly, find out the range R2. If you substitute in this formula, u square sin 2 into angle of projection is 60 by g. That means u square sin 120 by g. And this is also u square by g sin 120 is root 3 by 2. That is R1 and R2 you are going to get equal. So, here remember ranges will be same. This you can remember like this. If the sum of angles for a given velocity, remember, for a given velocity of projection, if theta 1 plus theta 2 is equal to 90 degrees, that means 30 plus 60 is equal to 90 degrees, then we call theta 1 and theta 2 are complementary angles. In this case, remember ranges will be same. This point you have to remember, this is the answer. So, whenever sum of the angles 90 degrees, 30 plus 60 90, those two angles are called complementary angles. Whenever complementary angles are given, ranges will be same, R1 is equal to R2. Therefore, 2 is the answer. A projectile has range R, time of flight t. Range is doubled. Some conditions are given, increasing the speed without changing the angle of projection, time of flight. And here we want the relation between range and time of flight. How do you solve the problem? Let us see. We know range is equal to u square sin 2 theta by g. And what is time of flight? 2u sin theta by g. Here there is no change in the angle of projection. And we want the relation between range and time. So, theta is constant, you have to eliminate as u was not given. So, how do you eliminate u? Let us square t square is 4u square sin square theta by g square. Let us do this. And now, I want to eliminate u square. So, let us divide these two. R by t square is equal to R is u square sin 2 theta by g by t square is 4u square sin square theta by g square. If you simplify, u square gets cancelled, Then what is r by t square? Let us rewrite sin 2 theta, I write 2 sin theta cos theta by here g and square gets cancelled, then g comes to the top, g by you are going to get 4 sin square theta. And in this, if you simplify, sin and square gets cancelled, then what you are going to get? R by t square is equal to half, 2 cancels here 2 times, cos theta by sin theta, cot theta, g you are going to get. So, this I can write r is equal to t square by 2 cot theta g. Now, we can say r directly proportional to t square because theta is constant, g constant. Given there is no change in the angle of projection and g also constant, here I eliminated u and there is no change in the angle of projection, then we got the relation r proportional to t square. So, I can write r1 by r2 is equal to t1 square by t2 square. Now, in the problem what is given? The range is double, that means r1 is equal to r, r2 is equal to 2r. Then what will be the time of flight? Substitute r by 2r is equal to t1 square by t2 square, r gets cancelled, t2 square is 2 t1 square, so t2 is root 2 t1. So, time becomes how many times? Root 2 times. Therefore, say t1 is equal to t in the beginning, then the time will be root 2 t you are going to get. So, the option is, second option is the correct answer option, and that is the answer. Now, let us see the 10th problem. 10th problem, the equation of motion of projectile given y is equal to ax minus bx square, where a and b are constants of motion. What is the horizontal range of projection? And you know, for a projectile, when it is projected at an angle theta with a velocity u, it strikes the ground in a parabolic path, that you know. Then what is the equation of trajectory? The equation of trajectory, you know, y is equal to ax minus bx square. Here full form you must know, where we know, if you remember, a is equal to tan theta, this you must know, and b is equal to g by 2 u square cos square theta. So, y is equal to, we can write tan theta x minus g by 2 u square cos square theta x square. This is the full form of equation of trajectory that you have to remember. From this, what is range? First option a by b given, second option root a by 2b given. We have to express range in terms of a and b. So, a is tan theta, b is g by 2 u square cos square theta. Then how do you get the range? What is the formula for range? R is u square sin 2 theta by g. So, from these two we have to obtain. How do you get that? Let us see at a and b. I can get this by writing a by b. Let us try the first option, a by b. If you write a by b, tan theta by g by 2 u square cos square theta. If you simplify 2 u square cos square theta by g, tan theta you write sin theta by cos theta, then cos theta and square gets cancelled. Then how do you write this? U square, this I will rewrite as 2 sin theta cos theta by g. So, you know that 2 sin theta cos theta is sin 2 theta by g. Therefore, this will be the range. Therefore, you have to remember always, in terms of constant, range is a by b. This is a standard expression that you have to remember. So, the option is 1, that is the correct answer. Now, let us discuss the next problem, that is problem number 11. Let us see that problem. A ball is projected upwards from the top of a tower with a velocity 50 meters per second, making an angle 30 degrees with the horizontal. The height of the tower is 70 meter. After how many seconds from the instant of throwing, the ball will reach the ground? That is the problem. It is also a two-dimensional problem based on projectile. Let us see how to solve the problem. In this problem, the point you have to note down is, it is projected from one point and reaching the other point. That is the point you have to remember. Let us see, this is the ground. Say there is a tower. This is a tower of height h. Suppose a person is standing here at the height of the tower that height of the tower was given 70 meter, that you have to note down. A ball is projected with a velocity u is equal to 50 meter per second, that you have to note down. And say this is horizontal, this line is horizontal, take this line as vertical, and this I take it as x axis, this I take it as y axis, say this is the origin. Now the ball is projected at an angle of 30 degrees with the horizontal, so this is 30 degrees. Then definitely it takes a parabolic path, because in a two-dimensional plane the motion of the body is a parabola, path of the projectile is parabola, therefore it traces a parabolic path. By the time it reaches here, it strikes the ground like this, somewhere here. Now we want to calculate what is the total time taken to strike the ground. So it was projected from the top of the tower and it is striking the ground. These two are different points, and this point is below the point of projection, that you have to remember. Then how do you solve? Here you resolve this velocity into two components. Whenever a two-dimensional problem is given, immediately you have to resolve the velocity into two components. U is, say, some u cos theta, and this is uy, say some u sin theta. Now we have to find out the time. This time is nothing but time of flight. It is projected here and striking the ground here. This time of flight you have to calculate. For that, what is the equation that you have to use, and what is the net displacement that you have to calculate? So in vertical plane we have to take. In vertical plane, that is along y axis. What is initial velocity? Initial velocity uy is equal to u sin theta. And as you have projected the body vertically upwards, a is equal to minus g. What is net displacement? That you have to calculate. Net displacement s is equal to, from here it is going to a height h in the upward direction. From there it is again coming down to this height, further it is falling down through a height h. So net displacement, when it is moving up, that displacement I take it as positive plus h, plus while coming down, what is the total height it has fallen? The total height it has fallen is h plus h. This is while coming down, this is while going up. Therefore, that I can take h. Here plus sign is moving upwards, here minus sign is moving downwards, because displacement is a vector quantity. So sign convention we have to follow. First it is going upwards, so plus h. As direction of motion is reversed, I am taking minus sign, minus of h plus h, total displacement. Then if you calculate the net displacement, h minus h, these two gets cancelled, s is equal to minus h, you are going to get. What is this negative sign indicate? Negative sign indicate it is falling downwards, because positive means upwards, negative means downwards. Finally the body is, no doubt, it is projected upwards, but after some time its direction has changed and it started falling downwards. So negative sign indicate it is falling downwards. Then what is the time taken? We have to calculate. Then use the basic equation, s is equal to ut plus half at square. This is the basic equation that you know in one dimensional motion, and that equation if you take, what is s? S is minus h, u is initial velocity u sin theta into t, you have to calculate, plus half a is minus g t square. Now you have to substitute this. If you simplify, h is equal to, you get half gt square minus u sin theta into t. This is the equation that you have to remember whenever you are doing this type of problem. Now all the numerical data was given, that data you substitute and simplify, you will get the time taken. H was given as 70, 70 is equal to half g, you take it as 10 into t square, minus what is initial velocity 50, as it is projected at an angle, you have to take y direction, because time of flight means the body is in air above the ground. Therefore sine angle is 30, sin 30 into t. So this you are going to get 5t squares, if you simplify, minus 50 into sin 30 half into t. Therefore you are going to get 70 is equal to 5t square minus 25t. So, a quadratic equation that you are going to get, if you solve, you will get the time. So, this if you solve, what happens? 5t square minus 25t minus 70 is equal to 0. If you write the roots and the time you are going to get 70, how do you write 25? 5 into 70. So, 5 into 70 you have to get 25. So, how do you write the roots? 5 into 70 you can write 14 into 5. Then 25 you are not getting. So, what are the roots of this? Otherwise, minus b plus r minus root of b square minus 4ac into 2a you have to take and you have to solve. Then you will get the answer as 7 seconds you have to get. Now, we have to find the roots. 5 into 70. How do you write this? 5 into 10 into 7. So, 7 5s 35 into 10. So, how do you write 5t square minus 35t, because minus 25 you require, 10t minus 70 is equal to 0. So, 5t, t minus 7 plus 10 if I take t minus 7 is equal to 0. Therefore, you are going to get t minus 7 into 5t plus 10 is equal to 0. So, t you get 7 or minus 10 by 5 you are going to get 7 or minus 2. But time cannot be negative. So, it cannot be minus 2 seconds. Therefore, time taken t you can take 7 seconds. So, the answer will be t is equal to 3 seconds as it is given in the third option. So, answer is 7. Now, let us discuss the next question. Question number 12. If you read that problem, it is a very important problem of two-dimensional motion. A ball is thrown with a velocity u making an angle theta with the horizontal. Its velocity vector is normal to initial velocity vector after a time interval of. How to solve this problem? Please follow it very carefully. It is a two-dimensional motion. So, let us take, this is x plane, this is y plane, this is origin. Now, a body is thrown with a velocity u at an angle theta. As you know that it reaches the ground in a parabolic path. Now, whenever it is reaching the ground in a parabolic path, time to time the direction of velocity what happens changes, because it is a curve. Time to time the direction of velocity changes. The direction of velocity is given by the tangent drawn at a point. Therefore, now you want to calculate after a time interval, velocity vector should become normal to the initial velocity vector. Say after a time t the particle is here, after a time t, and what is the velocity? Draw a tangent at that point. That gives the velocity v bar. Say this velocity is u bar, this velocity is v bar, and this is the tangent drawn at this point. As per our problem, this velocity should make an angle of 90 degrees. Normal means 90 degrees with this velocity. So, if you extend this angle should become as per problem 90 degrees. This happens after what time? This is the meaning of the problem. Then how do you solve this problem? That you have to see. First, the direction is in this direction. As it is slowly going up along the parabolic path, at one instant of time the direction of velocity is changing. That is given by the tangent drawn at that point. Now, this velocity and this velocity, this is initial velocity, this is final velocity after a time t. Both should be normal. Then time you have to calculate. To solve this problem, you have to write velocity in the vector form. How do you write? Let us see. Initially, you are throwing the body from here with a velocity u. Then, if you resolve this into two components, this ux will become u cos theta. This ui in vertical direction will become u sin theta. Then, how do you write this velocity? U bar is equal to, you can write any vector, you can write like this, ux I cap, uy j cap. Therefore, this I can write u cos theta I cap plus u sin theta j cap. This is initial velocity vector. Now, what is the final velocity vector? Final velocity vector after a time t, v bar you can write vx I cap plus vy j cap. Then, what is vx value? What is vy value? As you know, in projectile in the horizontal direction, there is no change in velocity. So, vx will be u cos theta only. In the horizontal direction, the velocity component remains the same, because in the horizontal direction, acceleration is 0. In vertical direction, it is minus g. And in vertical direction, what is that velocity? Vy. How do you calculate? Let us take V is equal to U plus AT, formula, basic equation. And in vertical direction, after some time I want V is equal to Vy. And what is initial velocity? U sin theta is the initial velocity in vertical direction, plus A is minus G, and after a time t, so Vy will become U sin theta minus Gt. Therefore, this is becoming U sin theta minus Gt. Therefore, how do you write this velocity vector? V bar is equal to U cos theta I cap plus U sin theta minus Gt j cap. So, this is the velocity vector after a time t. By using this, you can calculate Vx and Vy. In horizontal direction, as you know, you are getting only U cos theta. In vertical direction, you are getting U sin theta minus Gt. Now, when you know initial velocity vector, final velocity vector, you want to calculate the time when the vectors are perpendicular, velocity vectors are perpendicular. As you know, in vectors, whenever two vectors are mutually perpendicular, their dot product is 0. So, use the concept of dot product. You can write U bar dot V bar is equal to 0, because these two velocities are mutually perpendicular. As you know, the velocities in the vector form, here U is U cos theta I cap plus U sin theta j cap dot, what is final velocity? U cos theta I cap plus U sin theta minus Gt j cap is equal to 0. So, this dot product, if you simplify, what you are going to go, you know how to solve the, how to simplify the dot product. So, I components U cos theta if you square U square cos square theta plus j components if you take U sin theta into U sin theta minus Gt is equal to 0. If you expand this, you are going to get this. If you simplify, U square cos square theta plus U square sin square theta minus U sin theta Gt is equal to 0. You know how to expand dot product. From this, what you can write? Here you can take U square into cos square theta plus sin square theta minus U Gt sin theta is equal to 0. This, if you simplify further, U square as cos square theta plus sin square theta is becoming 1. This you take to the other side, U Gt sin theta, and U and square gets cancelled. I want after what time these velocities are perpendicular. So, that t, if you bring U by G sin theta is equal to t. That means after a time t of U by G sin theta, the final velocity is normal to the initial velocity vector. So, this will be your answer, and the options, if you see, third option is U by G sin theta, therefore, third option is your correct answer. So, this way you have to solve the problem. Now, let us see the next question, that is question number 13. This is also a problem of projectiles, two-dimensional motion. Let us see, from the top of a building 80 meters high, a ball is thrown horizontally, which hits the ground at a distance. The line joining the top of the building to the point where it hits the ground makes an angle of 45 degrees with the ground. What is the initial velocity of projection of the ball? It is a horizontal projection problem. Let us see how to solve this problem. There is a building. Let us say this is a building. And from the top of the building, this building is of height 80 meters was given. This is 80 meters. Then a ball is thrown horizontally with some velocity. When a ball is thrown horizontally with some velocity, I think this we have to calculate. And what are the conditions given in the problem? Now, this is striking the ground at a distance, the line joining the building to the point. It strikes somewhere here, say it strikes. It reaches the ground in a parabolic path and strikes here. From A you are throwing the body, and B is the foot of the tower. Say C is the point where it strikes the ground. Let us take. Now, this is the point where it strikes the ground. From here you are throwing the body. Then the line you have to calculate U, H 80 meters were given. And what is the additional information that is given in the problem? If you see, this is the point where you are throwing the body. This is the point where it is striking the ground. you draw a line joining these two. If you draw a line joining these two, it is making an angle of 45 degrees with the horizontal. With this information, you have to find out u is how much. Now, to solve this problem, as this is the building, you know that this angle is what? 90 degrees. So, it is becoming a right angle triangle. In this right angle triangle, h was given and this distance will become what? Range. How do you calculate range? Unless you know range, as h is given, you cannot calculate u. So, to find out the range, this angle is 45 degrees given. So, let us take tan 45. Tan 45 is opposite side AB by adjacent side BC, and tan 45 you know 1. So, what is AB? AB is nothing but height in the problem according to the diagram, and BC is nothing but range. So, you are going to get h is equal to r, and that is 80 meters given. So, now h and r both are same, then what is u? As the formula for range is u root 2h by g. In a horizontal projectile, you have to remember the formula for range. R is u root 2h by g. From this, as you know r and h, you can calculate u. So, range you got 80, u root 2 into height also is 80 by g. If you take it as 10 and you simplify, you will get the answer. Here 0 and 0 gets cancelled. So, 80 is equal to u root 8 to 16. So, it is very simple to solve. 2 into 4, therefore, u is 80 by 4. 80 by 4 is what? 20 meters per second. That means, if you throw the body with a velocity of 20 meters per second, this condition will be satisfied. So, if you see the options, third option is 20 meters per second. So, answer is 3. That is your answer. That way you have to solve the problem. Now, let us see the question number 14. And it's a very good problem, a very important model. Well, let us read out. A gun mounted on the top of a moving truck is aimed in the backward direction at an angle of 30 degrees to the vertical. If the muzzle velocity of the gun is 4 meters per second, speed of the truck you have to calculate. The condition is you have to send the bullet vertically up. That is the point you have to notice in this problem. And let us see how I am solving this problem. Please follow it very carefully. Let us draw a rough diagram. In this case, there is a truck. This is a truck with wheels moving on the ground, and now a gun is mounted in this direction. This is the barrel of the gun, let us say, and this barrel of the gun is making an angle 30 degrees with the vertical. This is the vertical. Say this is making an angle of 30 degrees with the vertical. That means this is what? 90 degrees. Now, from this, when you are firing a bullet, the bullet velocity was given. Muzzle velocity of the gun is nothing but bullet velocity. A bullet is coming out from this with a velocity of 4 meters per second. So, the truck is moving in this direction. You have to calculate what is the velocity of truck in this problem. Let us say velocity of the bullet is 4 meters per second. So, truck is moving horizontally, but with respect to the truck, bullet is coming out with a velocity of 4 meters per second at an angle of 30 degrees with the vertical. But in the problem, what should be the velocity of the truck so that the bullet move vertically up? That means this will be the resultant direction. Resultant direction of bullet. This is the direction of bullet with respect to the truck. When truck is moving, bullet is coming out, this is the resultant direction. So, if it has to move up, what should be the velocity of the truck you have to calculate. This problem you can solve by using parallelogram law of vectors, and in parallelogram law of vectors, the point that you have to remember is, suppose resultant is perpendicular to the given vector, then the direction, say this is alpha, you can say alpha is 90 degrees, this you take it as a vector, this you take it as a vector. What is the angle between these two vectors? Angle between these two vectors will be 90 plus 30 is equal to 120 degrees. Let us take this as one side of parallelogram, this as one side of parallelogram, and if you complete the parallelogram, then this will be the resultant. It is making an angle of 90 degrees. Then you know the formula, tan alpha is equal to the basic formula, if you remember, q sin theta by p plus q cos theta. let us say this as P, this as Q. Velocity of truck as P, velocity of bullet as Q. But here tan alpha, tan 90, tan 90 is infinity. Infinity means 1 by 0. Anything by 0 is what? Infinity. Therefore, if this has to become infinity, what does it imply? Denominator P plus Q cos theta should become 0. Unless this becomes 0, this cannot become what? Infinity. Therefore, from this we can write P plus Q cos theta 0. Now, we assumed P as velocity of truck Vt and Q as velocity of bullet Vb and cos theta is 0. Now, in this substitute the values, you will get the answer. We want to calculate velocity of the truck. So, velocity of the truck plus what is velocity of the bullet? Velocity of the bullet is 4 and theta, the angle between these two velocity vectors. This is 90 degrees, this is 30, 90 plus 30, 120 already I gave. So, this is cos 120 is equal to 0. Remaining is simple mathematics and you can use mathematics and you can solve the problem. Let us see how to solve. So, Vt is equal to plus 4 into what is cos 120 minus half. So, if you simplify, Vt minus 2 is equal to 0. So, the velocity of the truck is 2 meters per second. You are going to get, so your answer is fourth option as 2 meters per second. This is the velocity of the truck. This way you have to solve the problem. Now, coming to question number 15. 2 seconds after projection, a projectile is moving at 30 degrees above the horizontal. After 1 more second, it is moving horizontally. Angle of projection you have to calculate. This is also based on a projectile concept. It's a very important model. Let us see how to solve this problem. Let us draw the diagram of two-dimensional motion. This is x plane, this is y plane. In this, a body is projected with a velocity u at some angle, let us say. Here, u is not given, theta is not given, u is not given, but it is reaching the ground in a parabolic path. Now, how to find the angle of projection? Theta is angle of projection. What is given in the problem? If you see, 2 seconds after projection, you have projected here time 0. 2 seconds after projection, it will be somewhere here, let us say. Then it is moving 30 degrees above the horizontal. As you know, when it is moving in a parabolic path, curved path, the direction of velocity from time to time what happens? Changes. So, the direction of velocity will be in this direction. That velocity say v bar, it is 30 degrees with the horizontal. It is given in the problem. And what is given? After 1 more second, it is moving horizontally. What do you mean by moving horizontally? After 1 more second, up to here, it will take 2 seconds. From here, moving horizontally means at this point, at the highest point of the trajectory, if you draw a tangent, that tangent will be parallel to the horizontal. That is, it is moving horizontally. From here to here, suppose say this point is A, this point is O, this point is A, this point is B. At B, it is moving horizontally and the time taken is what? 1 second. This is the information given. With this information, you have to find out the angle of projection. So, if you consider the journey from O to A, let us consider journey from O to A. Time taken is 2 seconds. And consider the journey from A to B. Time taken is 1 second. Here it is moving horizontally means it is at the highest point. That means from O to B, it is reaching to the highest point. So, what will be the time of ascent? So, from these two, you can write time of ascent is equal to time taken to move from O to A, time taken to move from O to B. So, time of ascent Ti is equal to 2 plus 1, 3 seconds you are going to get. This is time of ascent. Because O to A time was given, A to B time was given, total time is 3 seconds, time of ascent. What is the formula for time of ascent of a projectile? U sin theta by g, this you know is 3 seconds. From this, what do you say? U sin theta is equal to 3g, equation 1. Here we want to find angle of projection and there are two unknowns u and theta. Unless you know u and theta, you cannot find out theta. So to eliminate either u or theta, you require one more equation. How to get one more equation? That we have to see from the problem. In this problem, what is given? One more point. From O to A, it is taking how many seconds? 2 seconds. This information is very much useful. Using this information, you have to get one more equation and one more point. After 2 seconds O to A, it is making an angle of 30 degrees. In a parabolic path, direction of velocity from time to time, what happens? Changes. Theta is angle of projection. Let us say this angle as alpha. If you remember the formula for tan alpha, what is the formula for tan alpha? U sin theta minus gt by u cos theta. This formula you have to remember, because what is the formula for tan alpha? Tan alpha is Vy by Vx. At any instant of time, if you resolve this into two components, this component will be Vx, this component will be Vy, and tan alpha will be Vy by Vx, and you can write Vy is u sin theta minus gt, and in the horizontal direction, you can simply, the direction, the velocity component in horizontal direction remains same. This is u cos theta. Here also it will be what? U cos theta. These are the two fundamental points that you have to remember. Then tan alpha, you will get u sin theta minus gt by u cos theta. This formula is useful in solving the problem. Using this, you have to get one more equation. And what is that equation? You have to get tan 30. Alpha was given, tan 30 is equal to u sin theta. Already you got 3g minus g. What is the time taken to move from here to here? 2 seconds was given. So it is 2 by u cos theta. Now, what is the value of tan 30? Tan 30 value is 1 by root 3 is equal to 3g minus 2g. You will get g by u cos theta. So from this, u cos theta is equal to root 3g, equation 2 you are going to get. Then you want angle of projection. From 1 and 2 you got the answer. And how do you get the answer? U sin theta, you divide 1 and 2 by u cos theta is equal to, it is 3g by root 3g. So g gets cancelled, u and u gets cancelled. Tan theta is equal to root 3 you are going to get. That implies theta is equal to how many degrees? 60 degrees. So the angle of projection is 60 degrees. Now let us see the options. Third option is 60 degrees. So third option is the correct answer for this problem. This way you have to solve the problem. Coming to question number 16. A projectile A is thrown with a velocity u1 at an angle 30 to the horizontal from point P. At the same time, another projectile B is thrown with a velocity u2 upwards from the point Q vertically below the highest point of A. For B to collide with A, u2 by u1 should be how much? That is the problem. Let us see how to solve the problem. In this problem, let us see, there is a projectile. It traces a parabolic path like this. Now, first projectile is thrown from A. This is projectile A. It is thrown from the point P at an angle of 30 degrees given. Its velocity is u1 and it is 30 degrees given in the problem. Now, it is moving in a parabolic path and it reaches to the highest point. From there it moves downwards. But what is given? At the same time, another projectile B is thrown with a velocity u2 upwards from the point Q vertically below the highest point. Below the highest point of this projectile, a point Q is there. From here a body is thrown vertically upwards. So this is projectile B, this is projectile A. It is thrown with a velocity u2. This is given u1, this is given u2. Then what is the condition that you want? B to collide with A. A is moving like this, B is moving like this. Now A and B have to collide. As it is moving upwards, B reaches here. As it is moving in a parabolic path, A reaches. So A and B have to collide. If A and B have to collide, what should be the value of u1 and u2 ratio you want to calculate? So here B has to collide with A. B has to collide with A means B is reaching to the highest point, A is also coming to the highest point. So times should be time taken by B is equal to time taken by A. So, these two times should be equal. Now, here B is moving vertically upwards. What is the time of ascent of a body projected vertically upwards? You know, time of ascent is u by g. So, for B, how do you write? u2 by g you write. And A is moving in a parabolic path. And what is the time of ascent of a particle moving in a parabolic path? That you know, u sin theta by g. But its velocity is u1 sin theta by g. So, these two times equal, then B and A will what? Collide. So, now if you simplify here, g and g gets cancelled. Therefore, it is u2 is u1 sin theta. But in the problem, we want to calculate u2 by u1. So, u2 by u1 will be sin theta, as theta was given as sin 30. Therefore, what is that u2 by u1 you will get? Sin 30 is what? Half. So, the ratio of u2 by u1 should be what? Half. So, answer is 3. So, 3 is the answer for this problem. Now, let us see question number 17. That question is, a large number of bullets are fired in all directions with same speed v. What is the maximum area on the ground on which these bullets will spread? Suppose you have a gun in your hand and you are firing the gun, and they cover some area. The bullets will fall on the ground in a parabolic path and they will cover some area. That area you have to calculate maximum area. What do you mean by maximum area? Maximum area implies the bullets have to fall at maximum distance. So, what is maximum distance? That maximum distance implies range maximum. So, what is the formula for maximum range that you have to calculate? As you know, R is u square sin 2 theta by g. If I want R is equal to maximum, that implies you know theta is equal to 45 degrees. Therefore, R will become u square by g. This is maximum range. R maximum will be what? U square by g. And here the bullets are fired with a speed v. So, R maximum will be v square by g. But you want to calculate the maximum area. As area is like this, the bullets will spread in this area and this is maximum range. This maximum range will be the radius of this circle, because the locus of these bullets, if you take, you are going to get a circle, then you are at the center and you are firing the gun. Bullets are falling on the ground in a circular path, if you say, then this maximum radius, maximum range will be the radius. Then what is the area that the bullets will cover? So, the formula for area is equal to, as you know, pi r square. That means pi r is maximum range square. Therefore, the area the bullets will cover is pi, and radius is nothing but r maximum. You know r maximum as v square by g. Therefore, if you write v square by g whole square, the maximum range that they cover is, if you simplify, v power 4 by g square. So, this is the maximum area the bullets will cover. So, the answer is 2. Pi v power 4 by g square is the answer for this problem. Coming to question number 18. A projectile is fired with a velocity v at an angle theta with the horizontal. The speed of the projectile when its direction of motion makes an angle beta with the horizontal. So, let us see how to solve this problem. This is a very important problem. Let us take a projectile. Divide the plane into two planes, x plane and y plane. It is projected at an angle theta with the horizontal. From here, it is projected with a velocity v at an angle theta with the horizontal. Then you know the trajectory is a parabola. So, the path is like this. It strikes the ground in a parabolic path. Now, what do you want in this problem? The speed of the projectile when its direction of motion makes an angle beta with the horizontal. As you know, when the projectile is moving along the trajectory, from time to time its direction of velocity what happens? Changes. Now, say after some time the projectile is here. I throw from here, but it reaches to the point P, and here it is given, it makes an angle beta with the horizontal. This is given. it makes an angle beta with the horizontal. Now we want to know the velocity here. What is this velocity? Let us say V prime is the velocity. What is this velocity? At this point you have to calculate. It is making an angle beta. To solve this problem, let us use the concept in a projectile or parabolic motion. What remains constant? In the horizontal direction, velocity remains constant, because in this direction acceleration is 0. Therefore, in this direction we know velocity is constant. So let us use this concept to solve the problem. Then the problem solution becomes easy. If you resolve this into two components, this component Vx is V cos theta, this component Vy is V sin theta. This is horizontal component, this is vertical component when you have projected the body at O. Now after some time it is at P, as it is given in the problem, it is making an angle beta with the horizontal. Again resolve this into two components. If you resolve this into two components, in this direction what is the component velocity? This component velocity will become V prime cos beta. You can resolve this velocity into two components. This component will become V prime sin beta, as V prime is the velocity. Now you want to calculate this velocity. Like if you resolve this velocity into two components, this velocity into two components, using this concept, what you can write? Let us guess. Here in the horizontal direction velocity remains constant. This I can write V prime x component. This I can write V prime y. But we know in the horizontal direction, as acceleration remains 0, velocity remains constant, because there is no force acting in this direction. So in this direction we can write Vx is equal to V prime x. These velocities are same. So this is V cos theta is equal to V prime x in horizontal direction is V prime cos beta. But we want to calculate V prime. So cos beta, if you bring to this side, V cos theta by cos beta is equal to V prime, where V prime is the velocity when it makes an angle beta with the horizontal. So what is your answer? V cos theta by cos beta is secant beta is equal to V prime. So when it makes an angle beta with the horizontal, then the velocity will become V cos theta secant beta. So the answer 3, if you see V cos theta secant beta will be your answer. So 3 is the answer for this problem.